Security in wireless sensor networks part 2. So, in part 1 we had seen we had gone through some of the important security requirements in wireless sensor networks, and we had also looked into the different challenges of implementing security mechanisms in wireless sensor networks due to different constraints, different limitations and so on. And thereafter, we also in first part we had gone through some of the few attacks that are possible on these networks. So, in the second part we are going to go through the rest of the different types of attacks that are possible in sensor networks. Of course, I mean we are not going to cover all of them, but only a few important well known ones, different types of attacks that are possible, and finally some solutions that have been proposed for security in sensor networks. So, this is another attack, a very popular one, which is called the wormhole attack. So, in the wormhole attack, as we can see that we have the network like this, we have the network of like orange colored nodes, and in the network an attacker can come in, and the attacker basically what it does, that it is going to maliciously it is going to maliciously get access to the data that is in transit in this network, and it is going to tunnel that data away from the network to another node, which is again the other part of this malicious entity, right. So, basically siphoning through a tunnel, it is going to siphon the data from the network out of the network. So, one or more malicious nodes are present who fake the route, one or more malicious nodes. So, they are going to fake the route, they are so it is sort of like this malicious entity, it is going to pretend as if it is part of the routing process. So, it is going to siphon the data out, it is going to it is going to pretend that it is a legitimate user, and this route is part of the regular network, and which actually is not, and the data is going to be siphoned out of the network to another malicious entity like this. So, the malicious node basically captures the packets and transmits them to the other location. The wormhole attack can be launched without any knowledge of the network, right. So, this is this is why it is called an attack. I mean, so if it was known to the different nodes, then it would not be an attack. So, nobody knows that this is happening, and this is why it's an attack, and it is called wormhole because of the existence of this tunnel between the two entities, two malicious entities. Then we have the selective forwarding attack. So, in selective forwarding, basically the malicious node, let us say that this is the malicious node. This malicious node, what it is going to do, it is going to deny the packets which are coming from a particular node or from selected nodes. So, then these packets are going to be dropped. Okay. So, if it is coming from particular selectively, if it is coming from certain node or couple of nodes, then selectively that data is going to be dropped. So, sinkhole attack is a type of selective forwarding attack, where one compromised node basically attracts all the traffic going to the base station. So, that is why it is called, this particular node is called the sinkhole. So, this sinkhole, so you see that this becomes a sinkhole, and the data, so that node itself is compromised, and it attracts all the data from the network that is going through it, and it would be so the data is going to be dropped in between instead of forwarding to the base station. Acknowledgement spoofing, as this name suggests, basically the attacker intercepts between the sender and the receiver, spoofs the acknowledgement packets, and the main goal is to make the sender convinced that a dead node is alive, right. So, basically it is spoofing, just spoofing the acknowledgement and pretending that, or convincing the sender that the dead node is alive. Compromised nodes attack, the attacker attacks some nodes in the network and steals the secret information like the security keys from these compromised nodes. So, physically the nodes are attacked, right. So, the nodes they themselves become compromised, and once the node is compromised, the security keys and other sensitive information are basically stolen, completely stolen from these compromised nodes. Node replication attack, here the attacker basically duplicates the node, and the duplicated nodes, that means the clone nodes, are employed in the sensor network. So, these clone nodes are actually not the real nodes, but these are just like virtual ones which have been created by the attacker, and because of this, these clone nodes, data are going to be sent through the clone nodes, which are actually not existing one, physically existing ones, and because of which this becomes an attack, and the data can be lost, data can be tampered with, that are flowing through these clone nodes. Attacks on information in transit, the name says it all. The data that are passing between the different nodes, they could be modified, altered, spoofed, deleted, and so on. So, this is very important. So, the data can be, the integrity of the data can be modified. I mean, the data may not be, the integrity of the data may not be maintained, and the data can be altered in different ways. Denial of service attack is very well known. Denial of service attack, basically, what you do is unnecessarily you want to send large number of different types of packets to the networks. Unnecessary packets are going to be sent to the network by the attacker, and that basically it's a resource constrained environment. Sensor networks are resource constrained, as I said before, and that basically is going to consume the target resources such as the network bandwidth, power, memory, etc., because of the unnecessary flow of too many large number of packets. There are different types of denial of service attacks that are possible. Denial of service attacks at the physical layer, data link layer, network layer, and transport layer. So, I am not going to go through each of them, but I am just going to highlight that this is a denial of service attack which is called the jamming attack, and this jamming attack typically occurs at the physical layer. So, it is a major physical layer denial of service attack, where the radio frequency is diverted to the other nodes, the data transmission is delayed, and the wireless sensor network nodes have limited resources. So, if jamming attack is detected, the sensor nodes go to the sleep mode and wake up cyclically to check the channel. This cannot avoid the denial of service attack. It enhances the lifespan of the sensor nodes by decreasing the power consumption. So, essentially what happens is that there is a high frequency, high powered attacker which is going to come and send signals at high strength into the network, and because of which the existing communication that is taking place between the different nodes, that is going to be affected, right, and that basically diverts the data that was originally being sent between the different nodes in the network, and also the overall transmission gets delayed. There are different types of jammers that are possible: constant jammers, intermittent jammers, deceptive jammers. Then we have random jammers and reactive jammers. So, in constant jamming, basically transmission between the different nodes are totally blocked. Okay. So, the data flow cannot pass from one side to another. So, constant jamming, it is a constant, totally blocked, the between the two nodes there is no transmission that can take place, constantly blocked. Okay. So, it is called constant jammer, it is done by the constant jammer, it is called constant jamming. Then intermittent jammer, basically intermittently it will jam, okay, intermittently it is going to jam. The sensor network is not jammed continuously or constantly like before, but for a specific duration of time and intermittently the message is going to be transmitted and then blocked. Deceptive jammer continuously sends packets without any gap between two packets. It makes the normal communicator fool to believe that the packets are coming from an authenticated user. In the random jammer, the jammer basically randomly it switches between jamming and napping, means sleeping. So, at the time of jamming, the attacker may act as a constant jammer or a deceptive jammer, but then it will go into the sleep mode, and it is going to alternately it is going to jams, nap, jam, nap, etc. But that cycle is itself going to be random. When it is going to jam, when it is going to nap, etc., that itself is random. Reactive jammers, basically when the channel is not active, the jammer remains silent. When the traffic becomes active, immediately it starts sending signal. Okay, so reactively it does it. So whenever the channel is active, jam; whenever it is not active, go to the sleep state. Now, physical attacks are also possible on sensor networks. These physical attacks can be of three types: active attacks, passive attacks, and location based attacks. Active attacks can take different forms, such as inserting error files into the system, actively altering the packets, modifying the packets, illegal access to the network, overloading the sensor network, etc. The main targets of active attacks are interfering with the functionality of the system, reduction of some sensor nodes from the network, modification of data, denial of service, performance degradation of the whole system. These are the different targets or objectives of performing active attacks. Passive attacks, eavesdropping, which we commonly know, is a form of passive attack. And these passive attacks can be classified into two categories. So, first is the attacker accesses the file being transferred, and the attacker then analyzes the traffic pattern and tries to find out the identity of the sender and the receiver and the frequency of transmission, and these information will be useful in future attacks. Okay, so, this is just collecting different attacks silently, eavesdropping, collecting different information for use in the future. So, it is sort of like stealth, some kind of stealth, that stealing the sensitive information passively, quietly. So, actively it is not hurting the network at that time, but later on that sensitive information that is collected through these processes like eavesdropping, that is going to be used in the future for launching other active attacks. Location based attacks classified into two types: external attacks and internal attacks. Attackers in the external attacks reside outside the network. Jamming is one such example. So, the jammer can reside outside. In fact, jamming, it is also possible to have the jammer inside the network as well, but typically it is assumed that the jammers are located externally, away from the network, and they are sending high powered beams with high signal strength, which are going to disrupt the proper communication between the different nodes, because it is a low signal strength environment. Signals are very low strength in these sensor nodes, and so if there is a high powered signal that is sent to these different nodes in the network, that is going to affect the proper functioning of these networks. Internal attacks, the attackers reside inside the network. They compromise because of these kind of attacks, the secret keys are compromised and the overall performance gets degraded. So, there are different security issues that have to be taken care of in wireless sensor networks as well. Context and design implications are there, integrity, authenticity, and confidentiality in different forms. We have seen them earlier in the first part of this topic on security in sensor networks. Context and design implications are there. One has to consider the intention of the hacker and the vulnerabilities of the system in order to take care of these issues. And we just to remind that we are dealing with a low cost, low energy wireless sensor network with too many different types of other constraints as well, and this type of this type of issues become very important. Integrity, authenticity, and confidentiality we have already seen before. Confidentiality talks about protecting the data from passive attacks. So, nobody who is not authorized should be able to get access to the data. Integrity is about that the data should not be modified in transit, and authenticity is that the data should be coming from the authorized sources. And these are the things that we have already gone through. Just to have a recap of these basic fundamental requirements of security on sensor networks. So, security protocols for wireless sensor networks, there are a large number of different types of protocols that have been proposed. I am just going to highlight these three protocols. One is the security protocol in wireless sensor network called the SPINS protocol in short. The second is the TinySec protocol, and the third is the LEAP protocol, localized encryption and authentication protocol. SPINS is a group of security protocols. It is not just one protocol, it is a group of protocols which will take care of issues such as confidentiality and integrity. And so, SPINS basically has two parts. One is called the SNAPE protocol, basically provides requirements, fulfillment of requirements with respect to confidentiality, integrity, privacy and newness, and it is employed in pairwise connection between the different nodes. So, pairwise keying, SNAPE basically does that. And the other part is the micro-Tesla, and it is applied in the broadcast method. It basically offers authentication and produces keys for message authentication code scheme. TinySec, it is a lightweight data link security protocol. It offers privacy, authentication and newness, and there are two types of approaches that are adopted in TinySec. One is the authentication approach, the other one is the authentication and encryption approach. LEAP protocol, I am not going to go through it, but just to give a glimpse of this particular protocol, there are 4 different types of keys that are used, a collection of keys. This is shared by all the nodes in the network, arrangement in the form of clusters. It connects the set of nodes in the form of a cluster, arranged in pairs. These keys are arranged in pairs. A key is shared between the nodes of each pair, and the single key is also used. So, it's shared with the base station. This particular single key is shared with the base station. So, here are the references. So, what we have seen so far are the different types of attacks that are possible on sensor networks, and we have also seen that there are different security protocols that have been proposed for sensor networks. We have first seen the SPINS protocol, which is one of the most popular sensor network security protocol that has been proposed. We have also seen the TinySec as well as the LEAP protocol, but mind you that there are many more sensor network security protocols that have been proposed and that exists in the literature. In these references, you would be able to go through a few more of them, so actually I would suggest that you please go through some of these papers, like the paper by Raymond and Midkiff, which was published in the IEEE Pervasive Computing. It talks about denial of service attacks and the different types of DOS attacks that are possible on the sensor networks, and the different solutions that have been proposed for it. But this paper is a bit old. It was published in 2008. Since 2008, there are a lot of other papers that have been proposed, and a comprehensive summary of different types of security mechanisms and different types of attacks and their counter solutions are available in the book by Obaidat and Mishra, published by the Cambridge University Press in 2014. It is titled Principles of Wireless Sensor Network, the first reference in this slide. So, with this we come to an end of the second part of the topic of security in sensor networks, and we have covered the security in sensor networks in 2 parts. First part was more focused on the security requirements, and the second part more on the attacks and the solutions that have been proposed for sensor networks. With this, we covered the entire topic of security in sensor networks. Thank you.